5.4 Dividing Polynomials. So in this sections, we're going to review how to divide by a monomial and divide by a polynomial in long division, and also synthetic divisions, which is only applied for linear divisor in a specific format. And the remainder theorems and factor theorems at last. So let's go back to reviewing dividing by a monomials. So when you have a divisor that is a monomial, then you basically divide each term by splitting out into fractions. So for example, A, you basically split it out into 3 different fractions because this is our least common denominator, which apply to every single term in the numerator. So we split it out into 3 different fractions. And then after that, we reduced each fractions, and the result is the same thing as dividing by a monomial. So when I reduce it on the first fraction, that will left with x. The second fraction, that will become 7 over 4. And the last fraction will be 3 over x. Because 4 goes into 12 3 times, and x squared and x to the third, they reduce it, become x. And that will be my final answer. So very straightforward and simple. So, however, you have to remember on the test to check what is the divisor. So in this case, example B, again, divisor is a monomial. So therefore, I can use this technique. So splitting out 6a to the second, b to the fourth, over minus 6a to the third, b to the fourth, minus 9a to the third, b to the third, over negative 6a to the third, b to the fourth, plus 4a to the third, b to the fourth, over minus 6a to the third, b to the fourth. And simplifying each fraction, that gave me negative 1 over a. So after you reduce everything, the numerator, you cannot have 0, right? You cannot have anything. So negative and negative, this will become positive. And when I reduce it, it will be 3 over 2, and then b in the denominator. And positive and negative will become minus. When you reduce it, it will be 2 over 3. A to the third and a to the third cancels out, b to the fourth and b to the fourth reduce it out. So therefore, this will be my final answer. So this is how we divide by a monomial. Now let's review on dividing by a polynomial in long division. So two things that you need to really check and then closely follow is, one, your divisor and your dividend must be in descending power, and any missing term, you need to replace it by a placeholder 0x to the n power. So let's review on the first example. And the first example, my dividend is in descending power. My divisor is in descending power already, so that's good. So now we can write it into long division format, which is k plus 6 divide into 2k squared plus 17k plus 30. Now, how do we divide? The trick is basically looking at the first term of the divisor and asking yourself how many times will exactly give me the first term in the dividend. So that means I have to ask k times what give me exactly 2k squared. So that will be what? 2k. And then you multiply this 2k to both of the term, so which will give me 2k squared plus 12k. And we know that in the long divisions, after you multiply, you have to what? Subtract. So we're going to be subtracting these terms. So when I subtract it, this negative sign will distribute it. So this will become negative times positive become negative. Negative times this positive will become negative. So now we have a new term to simplify. Right? We have a new operation to simplify now. So 2k squared minus 2k squared will become 0. Positive 17k minus 12k, that will become 5k, and then plus 30. And once we're done with that, we follow the same exact process. Okay, same exact process. That means I'm gonna now ask myself, here's the first term, how many times will give me exactly this first term? So I have to ask k times what give me exactly 5k. So that will be a positive 5. So that will be plus 5 right here. And after that, like before, I distribute it into both of them. So this will become 5k plus 30. And then after we multiply it out, we subtract. And remember, when you subtract, this negative is going to be distributed, so it becomes negative times positive is negative. Negative times this positive will become negative. So finally, when we do the operations, this will become 5k minus 5k is 0, and then positive 30 minus 30 is also 0, so my remainder is 0 in this case. My remainder is 0 in this case. So my final answer will be 2k plus 5. That will be my final answer. So now, let's continue on the next example. Okay. In this example, we can see that there are missing terms. So it is in descending power, but however, there is a missing term. So what we need to do is we need to uh, replace by a placeholder. Okay, so that will become x plus 2 divided x to 4x to the third, and we have a missing term of x squared, so I'm going to be replacing this x squared term with this plus 0x to the second power, and that's what I mean by right here, right? And then continue writing down the rest plus 3x minus 8. And we're going to do exact same process as before, which is going to start by the first term, go into the first term how many times. So I have to ask x times what give me exactly 4x to the third. 4x to the third. So, and we know that that will be 4x squared. So we multiply this 4x squared to both of the terms, so which will become 4x to the third plus 8x to the second. And after we multiply, we subtract. Subtract. How did that happen? You crippled it. Okay, we subtract. So when you subtract, this negative sign is going to distribute it. So this first term, the positive times negative will be negative. and this positive times negative will be negative. So we got negative 8x squared plus 3x minus 8. Copy down the rest, everything. And we're going to do the same process over again for the next term. So this one, we're going to look at the very first term with this very first term. So I have to ask myself, x time what exactly give me negative 8x to the second power? So that must be negative 8x. And we distributed this into both of the term again. So negative 8x times x will give me negative 8x squared. Negative 8x times 2 will give me negative 16x. And after we distribute it, we subtract. What happened? Okay, let me rewrite it again. Something wrong with this. So negative 8x squared. Now, I'm gonna subtract it. So when you subtract this negative, it's gonna distribute it. So negative times negative is positive. Negative times negative is positive. So therefore, negative 8x squared plus 8x squared will be 0. 3x plus 16x will become 19x minus 8. And finally, I'm going to continue my last step by doing the same thing again. X goes into x times what will give me 19x. So x times what will give me 19x. So that will be positive 19. Okay, something wrong with the technical issue. Right here it should be negative 8x. Okay, negative 8x. Okay, so now finally, continue. Sorry about the technical issue. Right? So finally, when I distributed this 19 to both of the term, that will become 19x plus 38. And then we're gonna be subtracting these terms together. So we distribute it, so it will become negative times positive is negative, negative times positive is negative. So 19x minus 19x will be 0, negative 8 minus 38 will become negative 46. So therefore, this problem we have a remainder. So my final answer will be 4x squared minus 8x plus 19 plus negative 46 over x plus 2. Okay, negative 46 over 8 plus 2. Continuing on the next example. So this one, we have to rewrite it into descending power. Okay, and putting a placeholder for my divisor, because divisor has a missing time. So when I write it down, this will become 2x squared plus 0x to the first power minus 2. That's for my divisor. And then go into my dividends, rewriting into descending power. That will be 2x to the fourth plus 8x to the third plus 2x squared, right? And then minus 5x minus 3. And after that, you do the same process to get the final answer. So, like before, the first term with the first term. So 2x squared times what give me 4x to the, I should say the 2x to the fourth power, right? 2x to the fourth power. So that will become x to the second power. So when we distribute it, we multiply it into every single term right here. That will become 2x to the fourth power plus 0x to the third power minus 2x squared. That's what we got. Then we subtract, right? Then we subtract subtracting it. So you need to distribute this negative sign. Negative times positive is negative. Negative times positive is negative. Negative times negative is positive. So when we simplify it, 2x to the fourth power minus 2x to the fourth is 0. Positive 8x to the third minus 0x to the third will be 8x to the third. Positive 2x squared plus 2x squared will become positive 4x squared. And then you write down the rest, negative 5x minus 3. And then we go over the same process again, right? Go over the same process again. So this time, the first term, right? The first term, this first term. So I ask myself 2x to the second power times what give me exactly 8x to the third. So that will be positive 4x. And then we distribute this 4x to every single term. So this will give me 8x to the third plus 0x to the second, right? Because 4 times x. And then the last will be minus 8x. Now after that, we subtract these two polynomials. So notice that it's same process over and over again once you get that. Distributing negative, so it become negative. Negative times positive is negative. Negative times negative is positive. So this gives me 4x squared plus 3x minus 3. Finally, our last step, which is this first term with this first term. So I ask myself 2x to the second times what give me exactly 4x squared. So that will be a positive 2, right? Positive 2. And then as usual, we simplify, right? We multiply, multiply it, so which is this will be multiplied to every single term. So that will become 4x squared plus 0x minus 4. And then we subtract. And that will give us our final answer. So distributing negative will be minus, minus right here, and then plus right there. So this will give me 3x plus 1 is the remainder. So finally, my final answer is x squared plus 4x plus 2, and then what? Plus 3x plus 1 over 2x squared minus 2. That will be my final answer on the long division. Now we're going to move into synthetic division. Dividing polynomial by another polynomial. You can use synthetic divisions if your divisor is in this format, x minus c. Okay, x minus c. So it is very specific format that we are talking about right here. Let me highlight that. So this part right here, x minus c. So only if it is in that format, then we can start basically dividing. So I wrote it down the procedure for you. What is the first step? What is the second step? What is the third step? But let's go along with the example, which will make it easier for you. So there will be a total of 3 rows in a synthetic divisions. Row 1, row 2, row 3. Okay, and row 1 we will write the coefficients of the dividends, and then also the same thing as before, you have to write down in descending power, and all the missing term you have to replace it by a placeholder 0. So my dividend, the coefficient of my dividends will be 4. Since the x squared term is missing, so I'm going to replace it by 0, and then x term, and then no coefficient. So you can see that 4x to the third, no x squared, 3, and minus 8. And we are dividing by c, right? You see that c? So it has to be in that format. So this divisor, x plus 2, is not in the format. So what we need to do is we need to rewrite this into the format as x minus c format. So that means this will be x minus a negative 2. That's how I have to look at it. And now I can see that this is my c right here. Okay, this is my c right there. So I will be using my c negative 2. So now that you get this, okay, now that you get this, so how do we continue? First, you bring down this leading coefficient down, always. And then you multiply that c with row 3. So that means you multiply negative 2 times 4, right? Negative 2 times 4, that will be negative 8, and you replace it in row 2. And then you add row 2 and a row 3 together. Oh, row 2 and row 1 together. So that will become negative 8, and then you write it down in row 3. And the same process, do it over again. So c times row 3, in this case, negative 2 times negative 8, which will become positive 16. You write it on row 2. Add row 1 and row 2. That'll give me 19. Then you multiply c with row 3, which will become negative 38. And you add row 1 and row 2, which is going to be negative 46. So how do we collect our answer? Notice that this is the 4 is the coefficient of x to the third power, and your answer is in row 3, which will be 1 degree less than your original one. So now my answer will be 4x squared minus 8x plus 19. And this part is my remainder, which is plus negative 46 over x plus 2. Continuing this synthetic divisions. So here we go. My dividends I need to rewrite into descending power, so it'll be 2, 8, 2, negative 5, and 3, negative 3. Then this is already in x minus c format already, so my c is 3. And always bring down the first coefficients into the third row. Now you can start the process. C times the third row, which will be 6 replace it in the second row. Add the first row and second row, that give me 14. Multiply 3 times 14, that give me 42, and write it into the second row. Add the first and the second row together, that would be 44. Multiply 44 times 3, that give me 132. Write it in row 2. Add row 1 and row 2, that give me 127. Now you multiply C with 127, so times with 3, right? That will give me 381. Add row 1 and row 2 together, that will give me 378. So originally I started with x to the fourth power, so my answer will be 1 degree less x to the third power. So my final answer is 2x to the third plus 14x squared plus 44x plus 127 plus, this is the remainder, 378 over x minus 3. So that is synthetic division. So you have to practice a lot of times to remember this process. You know, why are we good with like multiplying 3 digits with 3 digits? Because we practice it so many times. Right? Same thing. This is an algorithm that you need to practice. So the last thing that I want to talk about is dividing polynomial functions using the notation. So we saw that in add, subtract, multiply. Now it's division. Right? So let's take a look at on this example. F over g of x, according to the equivalent form, this is basically f of x divided by g of x. And what is f of x? That will be x squared minus 5x minus 24 over g of x is x plus 4. Now we need to divide it on this. So you may use long divisions or synthetic divisions whenever it is applicable. So in this case, my divisor is x minus x plus 4, which is a linear. We can use synthetic divisions. You can see that synthetic division write a lot of things less, so it could be a lot faster. But the catch is it must be x minus c format in your divisor. So for this case, we can rewrite it, our divisor, x minus c. So using the synthetic divisions, 1, negative 5, negative 24. And if I rewrite this into x minus c, it will be x minus negative 4. So my c is negative 4. So now, doing the process, bring down the leading coefficients. 1, negative 4 times 1 is negative 4. Add row 1 and row 2, negative 9. Multiply again. Negative 4 times negative 9 is 36. Add row 1 and row 2, so that will give me 12. That's the remainder. So we know that we started from x to the second power, so my answer must be x. So therefore, the answer right here will be x minus 9 plus the remainder, which is 12 over x plus 4. That's my answer. So if your divisor cannot be written as x minus c, then you have to use the long division format. Okay. Now, do the next example, which is this will be f functions evaluating at negative 4 divided by g function evaluating at negative 4. So in this case, we're going to have to evaluate f of 4, f of negative 4, and g of negative 4. So f of 4, f function is input square minus 5 times input minus 24 So I'm going to be substituting my input, which is negative 4, evaluating this, will give us 16 plus 20 minus 24, which is 12. For the second one, that will be inputs plus 4. So that's basically give us negative 4 plus 4 is 0. So I got 12 over 0, which in this case is undefined, is my final answer. Okay. So example number 5 asks us to evaluate f of negative 4. So that is basically f of negative 4. That will be negative 4 square minus 5 times negative 4 minus 24, which we already did that earlier, so that's why I'm doing very fast. So which will be equal to 12. And what I want to make a point is this remainder theorem. Okay? The remainder theorems allow us to get this value a lot faster, which is basically using your input, okay? Using your input as a divisor. So that means if I'm dividing, take a look at this. If I divide this function f 1, negative 5, negative 24 by my input negative 4 in the remainder theorem. So this brings down 1. Negative 4 times 1 is negative 4. So this gives me what? Negative 9. And that will be 36. And when you add it up, it will be 12, which we did that already before. Okay, which we did that right here on an example 4a. So what we get is this remainder right here is the same thing as the evaluating the function at 4, negative 4. So using the remainder, we can easily find out the remainder of the function, dividing two functions together. So in this case, use the remainder theorem to find the remainder of this polynomial function divided by x plus 2. So that means x minus a negative 2. So my c is negative 2. The remainder of dividing this function is the same thing as evaluating the function at negative 2, which we saw that right here already. Remainder and then function values are the same. So which will be negative 2 to the third power plus 4 times negative 2 plus 15. So that will be negative 8 minus 8 plus 15, which is going to be negative 1. So therefore, I know that my remainder for this will be negative 1. Remainder is negative 1 by using the remainder theorem. And this concludes this section.